Welcome, Algebra 1 to 1-3, real numbers in the number line. Essential question is, how are square roots and squares related? Let's begin. So a number a is a square root of a number b if a squared equals b. So our a and b are two variables. What does that actually mean? Well, let's take an example. If 7 squared equals 49, 7 is a square root of 49. Another example. If we did 5 squared, it equals 5 times 5 is 25. So 5 is a square root of 25. Now, this little symbol right here is called the radical symbol. It indicates a square root. It kind of looks like a check mark here, the hot bar going across. So this indicates a square root. So what I'll say in this example is the square root of 49, and you're going to say that as the square root of 49. The square root of 49 is going to be 7. Now what if we did this? The square root of 9 divided by 16. Well, this is a fraction. I can break that up into two parts. The square root of 9 over the square root of 16. And on the top, the square root of 9 is going to be 3. And on the denominator, square root of 16 is going to be 4. So that simplifies to 3/4. Moving on, a little bit more vocabulary. So we told you this symbol is the radical symbol. Inside the radical symbol, we call this the radicand. Another vocabulary word, perfect squares are squares of integers. So this will be 1 squared is going to be 1. 4 is 2 squared is going to be 4. 3 squared is going to be 9. 4 squared is going to be 16. 5 squared is going to be 25, and so on. If you have a times table, it actually forms a diagonal down from the top left to the bottom right. We'll show you that in class. Real numbers. Real numbers, this is a vocabulary word. They are numbers that you can graph on a number line. What does that mean? If I had a number like -2, could be a real number, because guess what? -2 goes right there on the number line. What about the number 1.5? 1 5/10? Well, this also can go on the number line. It'll be halfway between 1 and 2. So right here, that'll be 1.5. What about the number, let's call it square root of 8? Well, square root of 8, this is a real number because that number is actually, if you calculate that out, that number's around 2.7 something, and it keeps going, decimal goes on forever. So that's going to be about right here on the number line, about square root of 8. Real numbers are on the number line. Another real numbers, we can actually categorize these. So we have 3 categories. The first one is integers. Integers are any numbers that are positive and negative and 0. Not any numbers that aren't decimals or fractions. So 0, 1, 2, 3, 4, and we can keep going up forever. And we can go down. -1, -2, -3, -4, and keep going decreasing forever. Whole numbers. Whole numbers are 0 and all positive numbers. So 0, 1, 2, 3, 4, and keep going up. 0 and all positive integers, I mean. Natural numbers, this is a subset of the whole numbers. It's everything in the whole numbers except take away the 0. So it starts at 1, 2, 3, 4, and it keeps going up forever. Now, I said this word subset. What this means is that integers are all these numbers here. So it's everything. Whole numbers are a subset of integers because it has some of the integers but not all of them. And natural numbers are a subset of the whole numbers and natural and integers because it covers 1, 2, 3, 4, which whole numbers and integers have, but it doesn't have all the extras. So that's what subsets are. 2 other words for real numbers. We have rational numbers and irrational numbers, 2 categories. One thing about rational numbers, it's the quotient of integers. That's a definition you'll see a lot. What this means is you can write it as a divided by b, where a and b are integers. They're integers. So you could have a quotient could be 2/5. It could be -1/9. These are quotients of integers. Terminating decimals. That's another rational number. So what that means is the decimal ends. So 0.5, that ends. 0, let's go 0 and 125 thousandths. That ends. Doesn't go past 5. repeating decimals are another rational number. So I can have 0.111111 and it keeps going on. Or I can do 0.33333 and it keeps repeating that 3. These are repeating decimals. They are rational numbers. And the reason these are all rational numbers, I can write them as fractions, or quotient of integers. So the 0 and 11111, it actually can be written as 1/9. And 0.3333 is the same, it can be written as 3/9, which reduces down to 1/3. Same thing with the terminating decimals. 5/10 can be written as 1/2, and 125 thousandths can be written as 1/8. Irrational numbers. So these are the other type. These are decimals that neither terminate or repeat. So one common irrational number is number pi. And this number is 3.14, and then it keeps repeating different numbers. I don't remember what they are right now. But the numbers don't form a pattern. They don't repeat the same numbers, and they don't terminate. They just keep going on forever. So that would be pi. Another one could be square root of something that's not a perfect square. So like square root of 8 I used before. I said that was 2.7 something. These numbers keep going. They keep going on forever, and they don't repeat a pattern. So we can't write these as a fraction. So that's what the other point of this. Cannot write as a quotient of integers. I can't convert pi to some quotient a over b. You just can't do that. There aren't any integers where that will work. Moving on. Another thing with real numbers, we got inequalities here. So I got 4 different symbols. I got the less than, greater than, less than or equal to, and greater than or equal to. Here's what they look like on the number line. So less than means every number less than something. So if I wanted to graph x is less than 4, on the number line, it's going to look like this. I'm going to put an open circle at 4, and I'm going to point the arrow in the less than direction, just like this. So it's everything less than 4. For greater than, it's the opposite of that. X is greater than 4. So you're going to put an open circle at 4 and go in the greater than direction, everything bigger than 4. Now, less than or equal to. Similar to less than, looks like this. X is less than or equal to 4. You put a closed circle at 4, and everything less than that goes to the left, goes lower than 4. Put an arrow just like this. And greater than, x is greater than or equal to 4. You put another closed circle at 4, and then we go everything greater than that. The reason we do the closed circles is because we have to count the 4. So in these two cases right here and here, the bottom two, the 4 counts because it's or equal to, the or equal to part, or equal to. Now in the other cases, there's no or equal to, so the 4 does not count. We just want stuff under 4. We can't include 4 because 4 is not less than 4. It equals 4. Right, try this example. Pause the video. 2, 1. Okay, name the categories for the real numbers. So we had a few categories before. We had integers, whole numbers, and natural numbers, right? Well, let's look at square root of 11. We can't simplify that to an integer, so it's not an integer. It's not a whole number. If it's not an integer, it's not a whole number or a natural number. But we can ask, is it rational or irrational? It's actually irrational, because you can't simplify that down to a fraction of a over b. Now, -7. Well, it's actually an integer because it's an integer. It's a negative integer. But it's not a whole or a natural number because it's a negative, and that does not include it in those. Now, is 7 rational or irrational? Well, 7 could be written as 7 over 1, which is a quotient of 2 integers. So yeah, it is rational. Moving on. Okay, pause the video. All right, let's answer this. So order from least to greatest. Okay, and let's put them on the number line too, because that's fun. So yeah, you don't have to order these. Let's just put it on the number line. That's more fun. This -5, well, that's pretty easy. It just goes to the -5. I'm going to put a dot right there. Now, let's do 4 and 1/10. 4 and 1/10, well, that's a little bit bigger than 4. So that's going to go right about here. And I'm going to draw a dot that's just above the 4. Perfect. Square root of 16, that reduces to 4. So I just have to put that square root of 16 right at the 4 right here. And I'll just draw a dot off where that should go right there. So square root of 16 is equal to 4. Now this last one, 47 tenths. Oh, wow, these are all going to be cramped. 47 tenths, where's that in the number line? Well, that reduces down to 4.7. Same thing, if you convert it to a decimal, it's 4.7. Where's that on the number line? That is going to be just above the 5, or just below the 5. I'm going to put it about right here, and that's 47 tenths. And that's it.